All right, I think we're going to go ahead and get started. Thanks everybody for coming to the session today. Today we're going to be talking about IIS, and this is part one of two parts. We're going to be talking about the new investments in the IS-8 platform. So this one is called What's New with IS-8, Open Web Platform for Cloud. And we're going to be talking about a number of things related to cloud scale investments. And then we've got another talk on Thursday morning that's called What's New in IS-8, Performance, Scalability, and Security. We're going to take a deep dive on some of those additional features.
Right. We do have some content right at the end of this presentation. We'll talk a little bit about scalability. Between the two talks, we were able to fit it in here a little better. So right at the end of this one, we'll give you some scalability information as well.
Before we jump in, let us introduce ourselves. My name is Sean Egan. I'm a program manager on the IIS team. And my colleague Wade Hilmo is the development lead for IIS. And we'll both be talking throughout this presentation. So what do we want to talk about today? What do we want to get out of the session? So we're going to start with an overview of common web form deployment topologies and kind of what those look like, as well as some of the investments that IIS has made in improving that. And then we're really going to talk about some of the cloud scale investments we've made in the IS-8 platform. As you know, a theme of this whole event is the cloud and scale and that sort of thing. So IS-8 has made a number of investments in that space that we're going to be talking about today. So what you kind of want to get out of the session, both the Windows Core IS-8 investments, as well as some of our IS extension investments that we're going to be talking about in a moment, complement each other and really work together to enable the cloud scale investments for the next version of Windows. And IS-8 is the most secure, highly scalable, and easy to manage web platform for the cloud that Microsoft has ever shipped. We're really excited about this release, and we hope that you are too. So we're gonna start talking about web farm deployments a little bit.
Before we get into that, just to give us a little idea of what people's backgrounds are, how many people here today are currently running IIS 7.0 or 7.5? Most of the room is running that. How about IIS 6? Okay, so seeing less of IIS 6 than we have. And how many people are using it in an enterprise environment? Okay, any hosters, a hosting environment? We got some of that too. Great, thanks, it's good to know.
So what you see on the screen is a fairly common web farm deployment. So what you've got is a load balancer in the front with a web tier behind it or an application tier behind it. And then that's backed by a file server or database server. So this is a very common style of deployment. And what you see is that when requests come in, they can kind of be bounced to any server that you've got. So in this case, it's demonstrating a round-robin type load balancing algorithm. So we'll just go ahead. And so as you see, as requests come in, they're just balanced to any server. All the servers are identical in this kind of situation. And a request can be routed to any of those servers. So that's great. It's a very common solution. It's relatively simple. Your web tier looks exactly the same across all of your machines. It works great if you're scaling out a dedicated kind of environment, like if you've got a very large website and all of your servers need to serve the same content. Works very, very well for that. But when we're talking about hosting type environments or cloud sorts of environments with many different tenants, it becomes a little bit not as good of a solution. The reason for that, as you saw, that a particular site could be running on multiple of those servers, and that can be a challenge because they're using resources on each of those servers to run the exact same site. So if you've got a low traffic site, for example, sending one request to each of those 4 servers, it's going to be using memory on each of those servers rather than if you were to put them all on one, you'd just be using memory on one of the servers. Okay? So now let me show you another example, which is using some additional IS functionality. So we're going to be talking a little bit about application request routing. This is an IS extension that's shipped by our product team. It's freely downloadable on IIS.net, and it's shipped under the Windows supplemental license. So what that means is it's got the same support policy and everything else, just as if it was shipped in the box with Windows, but it's also available outside. And the one point I want to make here is it's also available. It works very well with Server 2012 that we're talking about today, but it's also available for IIS 7 and 7.5. So the difference in this scenario, instead of your load balancer that you had in the earlier example, you've now running application request routing with IIS on the front of it. So one of the things you can do, one of the features that we're going to talk about in a moment, is called hostname affinity. So as you saw, the first request came in there to www.contoso.com, and it went to a particular server. Got a different site, and that's going to go to a different server. But when another request comes in for Contoso, instead of being round robin to one of the other available servers, you saw that request went to the same server that served the first request. And the benefit of this is that now that www.contoso.com site is running only on that one server, only consuming resources on that one server, rather than having been load balanced to another server and using resources there. That's just one more. So the benefit of this topology is that it works very well if you've got a hosting type environment, cloud deployment, and you've got many different tenants. So rather than spreading them all out across all of your servers, you can affinitize them to one particular server and then save your resources that way. It just ends up being more efficient in terms of resource usage.
And with ARR, it's possible also to work in a similar fashion to the round robin. You could, if you wanted to, have that www.contoso.com sent to any subset of the set of machines. So if you wanted 3 machines to run that one, you could do that. So it would route each request to those 3 machines in round robin, or it could route based on client cookies, so we can have sticky clients to preserve sessions. Or you can set, as the slide showed, it's possible to just factor out so each machine in the back-end farm handles some set of sites that are only handled on that machine. In the case of a failover, we could then route it to a different machine, have the sites and applications spin up there, and give you the failover capabilities.
Okay. So let's take a look at how that actually works and how you can configure it. So I'm going to switch over to my demo machine. And what you're seeing now is an IIS 8 install. And in addition to the normal stuff you see in the UI, there's this new node here called Server Farms. And that's added when you install application request routing. So I've set up a demo farm already here. And I've added 2 servers to that. So the servers are called IIS 1 and IIS 2. So let's just take a look at some of the settings we have available, in particular the server affinity feature that I mentioned a moment ago. So what we're going to do for this example is actually use hostname affinity. So we've got this checkbox checked that says use hostname affinity. And we're just going to use a round robin algorithm in this case, which is one of the default algorithms that we ship. So I'm going to go ahead and just run a script here. And what we're going to do, I'll show you the script. What we're going to do is actually just start up 10 sites. So we're going to just create a request for 10 sites that we've got hosted on this cluster. And we're just going to kind of look at how they get affinitized to particular servers. So let's go ahead and run that. So we're starting up those 10 sites. And now let's take a look at how the affinity works there. So if we go ahead and hit display routing table, you can see, and then I'm going to type in the name of my first server, which is IIS1, and look it up by the server address. And so you can see hosted site 1, hosted site 3, et cetera. All the odd-numbered sites are affinitized to IIS1. And if we take a look at IIS2, you're going to see the corresponding even-numbered sites were affinitized there. So that means that any additional traffic that comes in for those sites is going to go to that server, and it will not go to the other one, at least based on how we've configured it so far. So let's go ahead and switch back to the slides. And just, by the way, if you have questions along the way, feel free to ask us. We're happy to answer things as they come up. Yes? Is the ARR load balanceable?
So you're asking if you can put a load balancer in front of multiple ARR machines. Yes, absolutely.
Great. Thanks for the question. So that kind of covers just a little bit of a common topology. So now we're going to talk a bit about, oh, that was my demo slide there. So let's talk a little bit about some of the other investments we made in IIS 8. And so with a theme of moving to the cloud and cloud-level scale, what sort of capabilities did we want to enable when we were designing IIS 8? So we want to be able to dynamically retrieve the configuration and content. So one thing I want to say about all of the demos I'm doing today, I'm using remote configuration as well as content. So those are they're stored on a central share, and all of the servers point to that share to get that configuration data and content. And the benefit of that is that any of your servers can then serve any site, and there's no local differences between machines that you need to worry about. You don't need to worry about moving content ever. It's always there in a central place so that any server can utilize it. So that's great if we can scale out more, but we also need to be able to start sites quickly. So we've done some work, particularly in the configuration area, in order to enable sites to start much more quickly. And we'll talk about that in a little bit more detail in a moment. In addition to that, we need to achieve high site density. So in the cloud world, being able to pack as many sites as possible on a machine is very important. And if you're a hoster, you know that site density is a key measure of your ability to be profitable and successful with your business. But while we scale up, we also want to keep everything easy to manage, and so that you don't have to do substantial extra work in order to enable your cloud-type scenarios. Okay? So now we're going to talk a little bit about configuration scalability. Do you want to introduce this slide?
Sure, I can speak to this a little bit. To kind of tell the story here, I want to roll back a few IIS versions. Between IIS 6 and IIS 7, we had a goal of changing our configuration store to go from a binary meta-based configuration that was not very easy to read or edit or manage on multiple applications. We wanted to move to an XML-based configuration, which is run within each worker process. So it gives us a level of scalability that we didn't have with IIS 6. We first shipped that in IIS 7, and again in IIS 7.5. And we learned some things when we saw customer deployments using the two versions that are out today. One of the things that we didn't anticipate when we shipped IIS 7 is that we would see a high volume of publishing changes. We went out and made an assumption that the configuration would be read frequently by many worker processes, but written to infrequently by a small set or even a single process. What we saw once we had it out in production is we saw servers running a large number of sites where the configuration itself became the scalability limit of IIS. We'd see things where the configuration would get very large and it would be stored in multiple processes, so we'd see high memory utilization. We saw situations where making a change to the configuration causes a notification to go through the system and causes us to do work to push that configuration change out to all the parts of the system that need it. What we saw, once you get a large enough number of application pools running, is we'd see substantial performance hits due to the machine working to process all the change notifications. So what we did for IIS 8 is we took a fresh look at how the configuration is being used, and we said, let's fix these scalability bottlenecks that we're having customers report to us. So as you can see on the slide, what we achieved in the work on the configuration is we've cut the memory usage by 50% for each instance of the configuration running on the machine. And in the case where you have a very large number of application pools on a machine, on the slide we've got 500 to 1,000 application pools on a machine, we get multiple orders of magnitude faster change propagation, and you don't see real high CPU usage on the system as we're trying to go through those updates. So these are just some of the things we did for Win 8 right at the start of the project to address customer issues that we were seeing in the 7.0 and 7.5 versions. I think Sean has a demonstration he can show you about this.
Absolutely. So let's go ahead and switch over. So what I'm going to do is I'm going to do some compare and contrast between Windows Server 2008 R2 and Windows Server 2012 and some of the improvements that have been made that Wade just spoke about. So I'm going to go ahead and start on R2, which is this guy here. I'm just going to show you real quick what the configuration looks like. So let's go ahead and load up IIS Manager. And what we're looking at here is a fairly typical hosting config. I don't know if you guys can see the number, but it's 3,378 sites are hosted on this particular configuration. And we also have a corresponding number of app pools, one app pool per site. That is a best practice in terms of how we recommend folks configure it, particularly for a shared hosting environment. What that does is it enforces process isolation between the tenants to ensure that no tenant can see each other's data or interfere with each other. So it just keeps that security boundary at the process level. So let's go ahead and actually do some work in here now. So first of all, I'm just gonna show you what we're doing sort of out of the box with nothing running. So right now I've got my IIS running, but I don't have any active sites at the moment. So just with IIS running and no active sites, we're using 411 megabytes of memory, just because we're aware of all of the 3,378 sites, but we're not actually running any of them yet. So that's fine, but let's take a look at what actually happens if we start up some sites and what that does to memory. So we're going to go ahead and start up 20 new sites. And it takes a little while, as you can see, to actually start those.
All we're doing here is we're sending one single request to each of the sites. And to get those 20 requests to be served, even though they're very, very fast requests, it took us this amount of time.
Right. It's a good point. They're all static file requests. There's no ASP.NET or anything in this particular demo.
Right.
So that's just to use the static file.
So and just to tell you what's happening here, WAS, the WAS, is the Worker Process Activation Service. It reads application host.config, and some of the data that's in application host.config is potentially sensitive for a particular application pool. If you had two different customers on the same server, you wouldn't want them to see each other's configuration. So what WAS does is WAS reads the entire application host.config file, parses it, separates it into subsets that are applicable for each application pool, and then on demand creates a temporary smaller version of that file for each application pool, and that temporary version contains only what that pool needs. And so what we're seeing during this amount of time is we're seeing WAS go through the application host.config and create 20 different copies of the application host.config containing a subset of the total data.
Great. So as you can see, the result of that was now WAS is using 720 megabytes, up from 411 earlier. So it's an additional 308 megabytes of memory, 75% more than what we started with, just to start up those 20 sites. So now let's take a look at Windows Server 2012 and show some of the improvements we've made there. So let's just start with the same thing we started with on the other side. So this is our idle memory consumption with no sites running. So we're about 334, so down from 411, in the range of 15 to 20% or so, just sort of out of the box with no sites running. But it gets more interesting when we actually start up some sites. So we're going to do the same thing as we did before, start up 20 additional websites. As you can see, that was a lot quicker. We didn't have that long delay while we were waiting for that to come back. And if you look at the memory usage, it's pretty much exactly what it was to start with. So 334, we used an additional about half a meg of memory, which is pretty negligible for starting those 20 sites. So with the improvements that we've made in the optimization of the config system, that memory is now not taken up by IIS, but it's given back to you to increase your site density and host more sites and get more performance out of your box. I want to show one more thing on this. Let's switch back to 2008 R2 again. And I'm actually going to start up some more sites, just so you get more of a feel for kind of what the performance looks like and the hit that you take by starting up sites. So I'm going to start 50 more sites, so we'll have a total of 70 running. We'll twiddle our thumbs here a bit while this goes. And it's just doing that same stuff we talked about before and generating those configuration files. Okay, so it took about 14 seconds to start up those additional 50 sites. So let's now do the same thing over here on Windows Server 2012. And we'll see that completed in a little over 1 second, so much, much faster to start up sites. And that's really important when you're in a cloud type of environment, being able to start up a site quickly when a request comes in, because obviously you don't have all of your sites running at the same time in a typical hosting environment. So let's go ahead and switch back to our slides now. So we're going to talk a bit about SSL. And before we get into the topic that is introduced here, we want to kind of lay the groundwork in terms of some of the challenges in working with SSL today. Wade, do you want to?
Sure, I can speak to that. So looking at what we're doing with SSL in current versions of IIS, there's a number of themes that we hear repeatedly from customers when we talk to them about SSL. One of the things we start seeing, the first question people ask is, I have 20 sites on the machine. They all have different host names, but they're all on the same IP and port. Can I give each of them its own site certificate? And the answer to that question is not currently. The reason you can't do that is because the host header that we use to figure out which site gets the request is inside of the HTTP. The HTTP is encrypted. You can't decrypt it until you select a certificate. So there's a chicken and an egg problem there that can't be solved with the current version of SSL. We'll talk about that when we talk about what we've done for Windows 8. The second thing that I want to talk about is the number of SSL certificates you can have on a machine. When we talk to people, particularly people hosting a very large number of sites, they're able to put a few thousand IP addresses and IP and port combinations on the machine with a certificate for each one of those. We can't go much further than that, not due to limitations in IIS, but due to limitations in the certificate store itself. The certificates for IIS 7.5 and earlier are stored in something called the My Store. And what the My Store is it's a Windows-provided per-user data store for the certificates. And for an individual user, probably not much need to put multiple thousands of certificates in it. But once you start using a product like IIS and you have many, many thousands of SSL sites, you start to see limitations. So we went to the team that owns the certificate store and we said, we need to improve this situation. And this is just a straight-up improvement we made in IIS 8. We had them write a new store for us. The new store is called the Web Store, and it works exactly like the store in previous versions of IIS, but instead of being called the My Store, it's called the Web Store, and it scales easily into the tens of thousands of certificates. And so that completely solves the problem of the total number of certificates. The next thing that we heard when we talked to customers is they said it is really difficult to manage certificates and SSL on IIS. How many people here are running SSL on IIS? How many people find it easy to manage? It's a very small number of hands by comparison. The reason for that is the management of SSL certificates is all associated with that certificate store again, and that functionality is provided by a team outside of IIS. Looks like there's a question right over here. The question is, does this resolve the issue of having multiple SSLs per IP? We have addressed that problem. It's not solved by any of the technology that I've spoken about before. It is solved by the feature that we're going to demonstrate here, which we call centralized SSL certificate support. And again, the issue that we run into is related to how to manage the SSL certificates. So in addition to getting a new store that works just like the old one, we wrote our own brand new certificate store from scratch. And the goal for us was to be able to manage certificates as easily as copying a PFX file into a share. And so if you want to set that up, you copy the file. IIS can be pre-configured to detect that you've put that file in there and just start using it without any further configuration. To answer the question that was just asked, we also have the ability to name a certificate in such a way that it can be selected for multiple sites. So if you have mysite.com and www.mysite.com, you can copy your PFX file in and just call it _mysite.com, and it will automatically apply to any sites that are under mysite.com. I'm sorry? So the question is about the security warning that's popped up from the browser. And that warning there's nothing that we can do from the server to stop that warning. What the warning says is it's a notification to the client. We think of SSL, or properly called TLS, we think of that as a way to send encrypted requests and get encrypted responses. But that's only a part of what SSL does. Another part of what SSL guarantees is it guarantees when you make a request out to the internet that you can be sure that you're talking to the server that you expect to be talking to. And that's an authentication piece of SSL. What that warning says that comes up in the browser is the warning says, hey, you told me you wanted to go to mysite.com, but I'm really going to some other site.com, and I can't authenticate to it. And that's what the warning means. So we can't make that warning go away. What you can do, though, is you can purchase an SSL certificate that either has what we call a wildcard certificate, which is star.mysite.com, which would address what you're talking about, or you can purchase a certificate that has multiple host names supported in it. So if you had my1site.com and my2site.com, you could purchase a certificate valid for either one. That'll solve the browser warning. What we've done with the centralized certificate store will simplify the management. Are you talking about server name indication, SNI? We're going to talk about SNI. We do support that in IIS 8. SNI will handle selecting the proper certificate, but the certificate still has to have the correct host name embedded in it, or you'll still get the warning. Great.
Okay. Ready to jump to some demos?
Let's jump to some demos.
All right. So
Hey, we have another question before we do that.
Sure.
That's a great question. Question is, how are the passwords for the PFX file managed? The answer to that question is in the My Store or in the web store. It's managed exactly the way it has been. There's no change there to the way it works. In the new centralized certificate store, we have a couple of different things you can do. You can set a password for the centralized certificate store. The caveat to that is that all certificates must have the same password. We can set it up so that there's no password on the certificate store. Here's an interesting thing that we found. Our competition, of course, is Apache. And Apache has worked for a long time on Linux with a file share-based store similar to what we're doing now. And we went and talked to customers using that and said, how are you managing the passwords? By far, the most common answer that we got is they strip the passwords. And so they don't. You can do that in IIS, but we don't recommend it. So it's possible, like I said, to set each of the files up with the same password. Alternately, I can't explain this well because this feature actually belongs to the certificate team at Microsoft. But if you're using a Server 2012 IIS 8 web server and the file share that stores your PFX files is also Windows Server 2012, Active Directory can uniquely authenticate each PFX file so that the files are password protected, but instead of you having to manage the password, it's done by Active Directory. And that feature just works out of the box with IIS 8.
Okay.
The question is, does it work for local or public CA certificates? The answer is either one. The certificate authority is a part of the handshake that's independent of our new stores. And the further question is regarding the passwords for the PFX files. That's also unrelated to the certificate authority. That's just one of the features of a PFX file is that it can be password protected. When Windows Server 2012 does the Active Directory level, that's all handled at the file system level. So it's independent of the certificate authority.
Okay. So let's jump into some demos. I'm going to start with Windows Server 2008 R2 again, and we're going to just kind of display some of the performance characteristics of the existing store so you can get a feel for, when we show the new stuff, how that performs. So I'm going to go ahead and just first show you what we're dealing with in terms of configuration. So launch INET Manager here, and you'll see we've got 500 sites in this particular configuration. And I'm going to launch MMC here real quick and also show the certs that we've got for that. So we're going to basically be taking a look at the My Store that we've referred to a few times here. So in the certificate store here, it's called the Personal Store in the UI. And you can see that we've got 500 certificates here as well. So for each of the sites that we've got configured, we have a corresponding SSL certificate. So I'm going to just go ahead and kind of show you what the performance of this thing looks like. So let's go ahead and start with just a query. So what we're going to do is do a directory listing of that store. So it just gives you a feel for, all I'm doing is a basic directory listing to see what's in that store. So I'm not opening the certificates in any way. I'm not doing anything with them. I'm just doing a dir command. So it took about 7.5 seconds or so just to do a dir on that directory. So it's fairly slow even to do a basic thing like iterating through the list of certificates. But now I'm going to actually start up a site. So what we're going to do here is actually start one site and send one request to that one site. And you'll see it actually takes a fair amount of time to do that in this case, because what's happening behind the scenes here is when we send that request to the one site, the certificate store, due to the limitations of that personal store, actually has to load all of the certificates that are installed in this machine, which we saw was around 500. So it took 13.5 seconds to do that. And
right, so this is not one request to 500 sites.
No.
This is one total HTTP request.
That's right.
And what we're seeing here is the amount of time the store takes to work through that.
Right. And it's not just about time. If you look at the next line, we used an additional 609 megabytes of memory just to serve that one request that we sent. And that's because all of those certificates got loaded into memory in order to be able to serve that request. So that's fairly inefficient, obviously, if it's that expensive just to do one request. So let's go ahead and look at the same kind of thing on R2. So I'm gonna start up INET Manager here again real quick, and we're not actually dealing with 500 sites anymore. We're going to show 10,000. We want to scale to the cloud. Let's show scaling to the cloud, not just goofing around with 500. So I'm going to show in the MMC where the web hosting store is. In this demo, I'm actually going to be using the centralized certificates feature.
Before you talk about centralized certificates,
sure.
Let me speak a little bit. A question came up a few minutes ago about SNI, or server name indication. And if I remember, I don't think we have a slide that covers that, but I want to talk about it because it's a great topic. So at the very beginning, I talked about the chicken and egg problem of figuring out what the host name is. SNI is a new specification extension to TLS. We say SSL up here all the time. SSL is kind of an obsolete specification. It's replaced by something called TLS. You can think of SSL and TLS as interchangeable, except the current version of TLS puts more data in the SSL handshake than previous versions. And included in that new data is the name of the target host site in the clear. So it's not necessary to decrypt the stream to figure out what the target host is that the request should be routed to. And so with support for SNI, we're able to have host header sites. So you can now have a few thousand sites on a machine using one IP address and one port 80, or port 443, and support unique certificates for all those sites. So that's great that we can support that. And our first version of centralized certificate store, which Sean is about to show you, works with that great. We took this feature to a number of large-scale hosting customers, and we showed them the feature, and they said, that's really, really great that you can do that, but does centralized certificate store depend on SNI? And the reason they asked that question is because it is an extension to the TLS specification. Not all clients support it. So we are actively collecting data on the IIS team. We work with a number of large hosting customers who are helping us by tracking. We provided a tool to them that they can just run on their IIS logs, and it will tell them what percentage of their clients today support SNI. We're seeing numbers in around the 70-ish% range. And so what they told us is they told us that we won't be able to use this new store if it requires SNI. Certainly, if you have clients that have SNI, it's available, it's great to use. We went back after that feedback from them and came up with a way to have the centralized search store work without SNI. So you still require a unique IP and port, but you can get the management ease that Sean's going to show you with this.
Great. And just to expand on one thing Wade mentioned there about the tool that our hosters have used to evaluate their data, we've actually made that available publicly on IIS.net just last week, in fact. So you're able to go and download that tool yourself and run it against your own IIS logs if you want to get a feel for the number of, or the percentage of your clients that support SNI. So I'm not going to demo it right now, but what I've done on Server 2012 is I brought up the MMC so I could show you the new web hosting store that we've talked about. It's the alternative to the personal store. So what you'll see, a very easy way to get benefit from this feature is just to move your certificates from that personal store to the web hosting store, and you'll see a dramatic performance increase just from doing that. It's very, very fast and scalable. Like we mentioned.
And it does not change any of your current. If you have practices in place to manage your SSL certificates today, it won't require any changes other than just using the other store.
That's right. What I am going to demo now is actually the centralized certificate store. And the performance-wise, it's very similar to the web hosting store in terms of the speed and the amount of memory that gets used. So I'm not going to actually show both of them. So let me come in here to the IIS UI. And we've got a new area in our UI here called centralized certificates. Let's go ahead and click on this guy. And what you can see in the UI here is we're loading a list of certificates. And where that comes from is a file share. So let me show you the way you configure this. So if you enable the feature, what you do is you provide it a path. So this is just a standard SMB file share. So you give it the path, and then credentials used to connect to that share. So it's generally a best practice to use a separate username and password for that. That's not something you use for anything else. And we talked a little bit ago about you can support private key passwords, and so where you would do that is you'd enter that here. The restriction that you need to be aware of if you're storing them in the centralized certificate store is they all need to use the same private key password in that case. So let's go ahead and make sure that there's no smoke and mirrors here. I'm actually just going to show you that it is, in fact, a share path. So whack machine name, whack share, and what you get is these PFX files that we've got stored in there. So these are just standard certificate files. There is a naming convention that we alluded to earlier, and I want to explain that in a little more detail now. So the naming convention allows us to, instead of having you specify the mapping between a site and a particular SSL certificate like you would do today, we can infer that mapping based on this naming convention. And the naming convention is essentially the site name .pfx. So if you've got a site called hosted site 1, your certificate is hosted site 1.pfx. To show some other examples, if your site is www.contosa.com, then your certificate is www.contosa.com.pfx. And so you can just put them in here, and then you don't need to worry about doing individual mappings and managing those bindings on each of your servers. As we also talked about the fact that we support wildcard certificates. And so the top one that I have highlighted here is a wildcard certificate. So you can see the naming convention there is an underscore in place of that star character, because we can't use that in the file system. Let's go ahead and close that out. And let's actually look at how it performs. So what we're going to do is we're actually going to do the same kind of test that we did on the other server. So if we just refresh our minds on the numbers, 13.5 seconds and 610 megs of memory to do this on R2 to start up one site, send it one request. Let's do the same thing here. And as you saw, that came back nearly instantly. I used 20K of memory, so no overhead comparatively to what we had on R2. So it's very fast, very scalable, very performant, and very efficient use of your memory.
Do you have a demo to set up one of these sites?
I don't.
Okay, well, we can speak through it really quickly.
Sure.
Just to give you an idea of the management difference between today and here. If you wanted to set up a new site, if you had newsite.com and you wanted to set that up, all you have to do is when you set the site up, tell it that you want to use the centralized certificate store.
That's what you do here. You pick.
So this is
HTTPS.
not. We didn't plan this ahead. We're just making this up as we go. So you just go in here, give it the host name. And then you've got your PFX file with your certificate in it. You just copy that PFX file into the directory, and you're done.
Right.
It now works with SSL. When it comes to the time that the certificate's going to expire, you renew the expiration by copying the new PFX file into the share.
I do have a demo for that one.
Great.
So we can show that.
We'll show that.
Just to kind of complete this scenario, though, what you do here, instead of selecting an SSL certificate like you would do in the traditional binding, once you pick that option to use the centralized certificate store, the SSL selection dialog gets grayed out. You no longer have to do that because of that naming convention. So let's go ahead and actually try some other stuff here. So I'm actually going to browse to one of the sites. Just so you know, this is going to result in a warning dialog when it comes up. So we're browsing to www.mystore.com, and what we're going to see when it comes back here is a warning dialog related to this certificate. Oh no, there's a problem with the certificate. I want to know what that problem is, so I'm just going to go ahead and continue to the site and take a look. So if we look at the certificate up here, we can see, oh no, the certificate has expired. So this is telling me you've got an expired certificate here. If we look at the certificate, we can, in fact, see that it expired last July. Probably should get a new certificate. So deploying a new certificate when you need to renew is very, very simple. So what you do is you just actually copy your new certificate file to the share. So we'll just let that, just making that file copy is all you need to do in order to get your new certificate deployed. And the way this works, because we don't control the file server, you may be storing it on a NAS that doesn't support file change notifications or that sort of thing. We actually have a polling interval for this one. So we'll poll every 5 minutes by default, but you can adjust that polling interval if you want. So let's try browsing to the site again. And this time, we should not see a warning dialog because we should be using that new certificate. And sure enough, it comes up, no warning dialog. We're automatically using that new certificate that we just deployed by doing a file copy. I also want to show really quick the support for wildcard certificates and non-wildcard certificates. So what we try to do when you've got multiple certificates is we try and do the most precise match first, and then if there's not an exact match, we will fall back to a wildcard cert. So I'm actually going to show you kind of what certificates would be in play in that sort of situation. So I've got a certificate down here for www.contoso.com, and I've also got a wildcard certificate for star.contoso.com. So if we look at how that is actually going to play out, we'll go ahead and launch www.contoso.com. So in this case, because we have an exact match of that certificate, we should see that it's going to use that exact match, not the wildcard match. So let's check the certificate to verify that that's the case. So if we look at the certificate, we can see, sure enough, this was issued to www.contoso.com. And then let's switch it over to something that's not www, like images.contoso.com. Give that just a moment to render here. Taking just a sec. Okay, so this one's come back. And of course, we don't have an exact match certificate for this one, so we should see that it does use that star.contoso.com wildcard certificate that we've got configured. Okay, that wraps up our SSL-related demos. I'm going to go ahead and switch back to our slides. Okay, our next topic is about resource sandboxing. So now that we can scale to more customers, you can have more sites on a particular farm, we perform better, you're going to want to pack more folks on the same kind of environment. But how do you do that in a way that doesn't let those customers interfere with each other? If you've got a very popular site, for example, maybe it uses up a lot of your CPU, a lot of your network bandwidth, and it starves those other tenants that are hosted on the same environment from being able to use it. So the solution to that is resource sandboxing. And so IIS supports a number of types of resource sandboxing. So we're going to be talking about network bandwidth today. But we've got a talk on Thursday where we're actually go into detail on the new CPU throttling feature. We also support throttling on storage space and memory consumption. But today our focus for this demo is going to be on network bandwidth and kind of what that looks like in terms of ability to sandbox a particular tenant. So let me get this going here. So I'm going to switch back to my AR machine. And what I've got is I've actually got a way to do load. So in order to demonstrate that a site is using a lot of resources, I've actually got a tool here that's going to throw load against the site so we can see the effects of that sandboxing as we do it. So I'm going to go ahead and just run that tool, let it do its magic. The tool is called WCAT. So this is a tool that is produced by Microsoft. It's freely downloadable on Microsoft.com. And it's basically just a way to throw a lot of traffic at a particular site. We use it all the time for demos. Some of our customers use it for testing and that sort of thing to get a feel for requests per second that are supported by their site.
Sometimes when I go to these talks, people will ask me how we measure performance and how we improve IIS performance internally. All of our performance data that we collect and all of the analysis that we do is driven by this particular tool. It was written a number of years ago. It started on the IIS team. We wrote it as kind of just a test tool off to the side. The Windows fundamentals team at Microsoft, they're responsible for a set of tools and general Windows performance beyond just the web server. They've kind of taken ownership of this and released a version of it, which is what we have on IIS.net. But this is the way that we do collect all of our performance data internally.
Great. So the site that we're actually hitting with all this traffic is the default website on the IIS-1 server. That's one of our servers here. But let's go ahead and check out where that blog site is affinitized to. So you can see that we entered this in the routing table on server affinity on application request routing, and it's affinitized to just one server, IIS-1. And so if we look at what performance we're getting out of that and what RPS, I've got a perfmon set up here. We'll go ahead and launch. As you can see, it's starting to kind of go off the charts as a baseline. So it's doing more than the 300 RPS that we've got configured as the scale here. So throwing a lot of traffic at that. So you're gonna see impact on other tenants if you're doing that level of traffic. So how do we do that, and how do we configure the sandbox to prevent this sort of issue? So let's jump over to IIS-1, which is where this site is running. And we're going to look at, let me bring the default website. Oops. Default website. Okay. So we have a couple of ways to limit. What we're gonna actually use this limits feature over here to do network, but I want to show you really quick, just to introduce some of the other throttling settings we have. So on the application pool, if you go to the recycling tab, we can recycle based on memory usage. So if a particular application is badly behaved and using a lot of memory, we can recycle that application so that it doesn't take all the memory away from other customers.
Probably important to point out, we're talking about throttling here. This specific feature is not a throttle. We set out, when we started working on IIS-8, we said, hey, let's throttle CPU usage. Let's throttle memory. And what we found when we throttled memory is that it kind of got us into a worse situation than what we do today. We had it set up so that you could cap the amount of memory that a particular process used, and as soon as it tried to use more memory than that, we would limit it there. What we started seeing is it consuming more and more page file, and so even though there was memory available on the server, you'd start paging and then you'd start running low on disk resources. So for this specific feature for memory, instead of throttling it, we cap it. And the feature exists in previous versions of IIS as well. As soon as we reach the memory cap, we'll just recycle that worker process. We will allow it to start up again, and once it starts up again, hopefully it'll start it'll start over with its memory usage again. But I just wanted to speak specifically about the fact that this is a cap and not a throttle for memory, and why.
Yep. Another option that we have in IIS is to do CPU throttling. So that's under the advanced settings of your application pool. I'm not going to go into detail about it here because it's actually part of our Thursday talk. But if you're familiar with the previous version of IIS and the CPU throttling feature, we had something like that. We've made it much, much better. It's very compelling now compared to what we had in the previous release.
What you have today in IIS 7.5 and earlier is, again, you have a cap. When we detect that you've used more CPU than you're allowed to, we'll just shut you down for a period of time. No requests will go through. If you come to our talk on Thursday, we'll show you how we handle that situation today in IIS 8.
All right. But back to our default website, because we're gonna use the network bandwidth limit here for this particular demo. So that's configured under the limits link there on the right-hand side. And so you can limit bandwidth in bytes, or you can do a limited number of connections. We're gonna do it just on number of bytes for this demo. So we're gonna go for 256K of bandwidth is all that particular site is allowed to use. So let's go ahead and apply that. And let's take a look at the effect that has on the server. So if we go back to our ARR machine where we've got our performance monitor running, you can see that we dropped from 300 consistently down to around 50-ish or so due to that limit. So we've taken the guy who was consuming all the bandwidth and throttled his site back, so he's only using only allowed to do about 50 RPS because that's the amount of bandwidth we've allowed him to use. And you may have different size throttles for different customers. You can set that up on a per site basis. So that's a kind of some additional flexibility if you have some sites that are allowed more and some sites that are allowed less.
And we should also point out this is a network bandwidth throttle, not a request per second throttle. So if we were to use smaller responses, you'd see this number in Performance Monitor higher. With larger responses, you'd see this number smaller. So we just wanted to clarify what we're throttling.
Yep. So that's kind of a basic example of resource throttling. So I'm going to go ahead and switch back to our slide deck. And we're going to talk about scalability and elastic scalability. So what this really means, we're talking about two separate concepts here. The first one is what we call per customer elastic scalability. And what that means is we want to be able to easily scale what level of resources a particular customer is allowed to leverage. So if you recall from the blog site example I just showed, he was affinitized to one server. But if this is a popular site and the customer wants to pay more for additional hosting capacity, we can then affinitize him to 2 servers or more. And that's a very simple operation that I'm going to demo in just a moment. And the other type of elastic scalability is to be able to scale out the actual hardware in your web farm. So we've got two servers in the demo that we've showed so far. We're going to look at what it looks like to add a third one and make that available to the farm. So let's go ahead and jump back over there. So we're gonna remain here on our ARR machine. Pardon me. One of the options that you have right here under Advanced Settings, under Server Affinity, is the number of allocated servers. So we're going to go for blog site. And we're going to say, instead of the 1 that he was on before, we're going to allow him to be affinitized to 2 now. And so now, if we check the routing table again and look at blog site, sure enough, you can see that now that site is affinitized to 2 servers in our farm. And if we look at our performance monitor to see what effect that has, you can see there's a pretty immediate jump to the number of RPS that are supported because now he's got that additional server that he's running on. It was also still limited to 256K, but that's on the other server as well. So the sum of those, it roughly doubles the amount of RPS that customer is allowed to do. It's just a simple configuration change to enable that level of scale out for a customer site. But what if we want to actually add hardware to our farm so that because we're running low and we want to add additional capacity? So what I'm going to show now is what it takes to add a server. So I've got another VM here called IIS3, and this is a clean install of IIS. So there's nothing configured. You can see we've just got a default website, the basic application pools that come with it by default. But I haven't done any additional configuration, and this server is not a member of the farm. So what does it take to actually add that server to the farm? Let's walk through it. So the first step is to enable shared configuration. And what this does is it allows us to share the same configuration from the central store that the other servers are using. So I'm just going to go ahead and configure this. Hit apply. And enter my encryption password there. So now we've set up shared configuration and enabled all of those additional sites on this server. And the next step is to enable centralized certificates. Because these are secure sites that we're dealing with, we want to also point to that central share to pick up our certificates. So let's go ahead and do that. Okay. Enable that, and if I refresh, you can see the certificates are already coming in there from the UI. But if I refresh my user interface here, we'll see that now all of those sites that we'd configured and that are configured on those other servers in the farm are available here as well. There is one final step that you need to do in order to sort of hook everything up, and that's related to the SSL binding for that central cert store. So if we look at the bindings that are set up, by default, there aren't any. So there aren't any SSL bindings that relate to the central cert store. So what we're going to do is, I'm going to show you the script here. We're just going to create that single binding that is used for the central cert store. And so you have just one binding that represents everything on the box. So let's go ahead and run that. Okay, we've added that certificate binding now, and let's just oops.
So this binding, when we showed you before, when you go through the user interface, if you use centralized certificate store, the SSL configuration button grayed out. Normally what would happen if you added a site and used SSL, you'd complete the dialog to do the SSL binding. That would push the configuration through to HTTP sys underneath IIS to set that binding up. What we've done with the centralized certificate store is we have a single binding that basically says, for any SSL stuff that comes through here, don't use the regular certificate stores, use the centralized certificate store instead. But there's no place in the UI where you set that binding. So this is what the setting here does.
Right. So what I'm going to do now is actually just request one of those sites, and just to make sure that this server is fully up and running and can serve sites through SSL. And as you see, it worked. Request came back very quickly, used a little bit of memory, but that just shows us this server is in fact working and able to serve sites from that shared configuration and from the centralized certificate store. So that's great. We've got our new server fully up and running, ready to go. So it's very simple then to add it to our farm. So let's go back to the ARR machine, and we've got the servers node here. You can see there's two. So let's go ahead and say add server. New server's name is IIS3. Add it. Very good. And now IIS3 is added to that server farm and is available to serve requests. So if we want to look at extending that blog site a little bit further, we can actually do that. So instead of saying he can have 2 servers, let's actually let him have 3. And so now if we look at the routing table, you can see, oops, he's actually affinitized on all 3 of those servers. So he can, and if we look back in the UI, you would see that, again, there's that corresponding performance increase, an additional throughput that comes from having an additional server to serve load there. But as you saw, that was pretty quick, maybe a couple of minutes to configure our centralized configuration, centralized certificate store, add that binding, and then add the server to my load balancer ARR in order to serve requests. So let's go ahead and switch back to our slides. Numa.
So we want to take the last part of the talk and talk about, we've been talking about scale out, pushing IIS to different machines. We've talked about increasing the SSL scalability. Now I want to talk a little bit about scale up, what you can do with a single machine. On this slide here, we work with some hardware vendors on a pretty regular basis to figure out what direction hardware is going. And what we're hearing is that the future is more cores on a single CPU. So what we expect to see in 2014 is a commodity server is going to have between 16 and 64 logical cores. Definition of a logical core in this case, if you have hyperthreading, that's 2 logical cores per physical core. So we're talking about a machine here that has 32 physical processors on it with hyperthreading, or in some cases you might see 64 physical processors. We're talking about there's NUMA architecture. How many people here know what NUMA is? A few. I'll go into it a little bit. This will kind of lead the next slide. NUMA stands for non-uniform memory access. And what that means, currently, when you put a computer together, you're looking at your memory and your CPUs and a single bus that transfers data between the memory and CPU. As you put more and more CPUs on the machine, you run into scalability limitations on that bus. And the way that that problem gets resolved with NUMA is you have multiple sets of memory that each have their own bus that's associated with some set of processors. And so you may have 64 processors on the machine, but you might have 8 different memory buses. And that would be configured so that 8 processors have their own set of memory, another 8 have a different set of memory, and so on. And you need to keep that in mind when you're working on the software at our level, because accessing memory locally that is in your NUMA node is very fast. Accessing memory, you can still access memory if it's in one of those other NUMA nodes, but there's a performance hit to do so because the data needs to be moved across a different bus to get into that processor. So that's kind of what the future architecture looks like. We expect these commodity servers to have up to 64 gigabytes of RAM. We expect to see 40 gigabyte NICs on these machines and probably $300 to $1,500 range for one of these servers. This is radically different. When I started working on IIS, which was 14 years ago. 14 years ago I started working on IIS. What we saw was people running commodity machines that were a single processor with a gigabyte of RAM or less. And historically, we've seen people running web servers kind of stay to the minimum. A lot of times we saw people running blades with 2 processors. As we started getting multiple cores, we'd see people running 2 physical processors and 4 cores. What we're starting to see today is we're starting to see customers moving away from those commodity machines and running bigger servers. So we're also looking a little bit at the high end, where we expect that there will be servers available with between 256 and 512 logical CPUs on the machine. So we really need to do some things to make sure we work in that environment. 2014 is well within the lifetime of Windows Server 2012. So the NUMA concepts, I kind of covered the NUMA concepts a little bit already. We know going into it that accessing non-local memory is slower, so we want to figure out what we can do to help that out. There's another concept I didn't mention called a processor group. The way Windows works internally, Windows doesn't allow you to have an arbitrary number of processors associated to one processor group. It limits it to 64. So you can have 64 processors in a single group. And if you want more processors, you have to have additional groups. So we're testing on machines right now that have, I think the biggest we've tested with is 100 and, we've tried a machine with like 192 processors on it, and that's got multiple processor groups. We've had to make some changes to IIS to allow all this to happen. The first change in IIS 7.5 and earlier, we have the ability, it's kind of an arcane ability that we don't expose through the user interface, but you can affinitize your worker process to run on specific CPUs. Right now, that's a 32-bit mask, so IIS 7.5 can't support more than 32 processors with affinitization. We've added a second processor mask. That gives us 64 bits. And so you may say, okay, so now you can handle 64 CPUs, but what happens when you have more than that? That's where the processor group comes into play. So you can take an application pool and you can say, I want to affinitize you to this set of processors and that processor group. It's kind of difficult configuration. To do that correctly, you need to know exactly how your machine is set up. You need to know which physical RAM maps to which CPU. You need to know which network cards affinitize to which particular CPU in order to do that. And we expect that some people will go to the trouble of learning all that. But we wanted to make it a little bit easier. So we've added automatic configuration in IIS 8. I can't do a demo on this because we don't have one of these machines here. So some of the features don't light up in the user interface until we detect a NUMA machine. But you can go in. You used to be able to set. Let's go ahead and switch back to the demo machine. We can show that.
Sure. Yeah.
Okay. Sorry, this is unscripted. So under application pools, we can go to the default application pool. Under advanced settings, maximum worker processes. This number right now is set to 1, and currently it has to be between 1 and, I found this funny when I looked at the validation. We validated that it's no lower than 1 and no higher than 2 billion in 2 complement numbers. I don't expect people will set that number that high very often, but we did add a new number in IIS 8. We allow you to set it to 0. And what 0 does for you is 0 tells IIS, go out and inspect the machine's hardware configuration. Find out how many NUMA nodes exist on the machine. And we're going to make an assumption. We're going to assume that if you start a worker process, you want it logically bound to all the processors in a particular NUMA node. And if you don't let the site run, don't let the data run outside of that, we know that we're going to be getting local memory access. So we do that for each NUMA node. So on a 64-core machine with 8 NUMA nodes, we would set up 8 worker processes. And then under the covers, we would affinitize each of those worker processes so its threads only ran on local memory sets. We use something when we do that we call soft affinity. We distinguish that from what we call hard affinity. What you might be used to today is hard affinity, which says this process is allowed to run on these 3 processors. No matter what you do, if you're affinitized, only those 3 processors will be used. That's hard affinity. What we do by default in IIS 8 is we do what we call soft affinity. That says, try to run everything on that particular set of processors. But if those processors are really busy and you still have work to do, then go ahead and spill over and start using some of the other processors, even though they'll be slower. And we do allow that to happen. We've done a lot of testing in this area, and we find that that gives us about the best balance. Gives you very good performance without having to know the details down to the bus on the machine you're running. I don't have any numbers I can publish, but I have some numbers from some of the testing that we've seen that I can go over here. Yeah. The question is, how does this feature go together with the central configuration? I assume you're asking about the centralized certificate store.
Oh, shared config.
Oh, the shared configuration? Mm-hmm. It works seamlessly with that. Yes, this setting can be made in the shared configuration. If you have 10 machines and they're all sharing the same configuration, and you set that number to 0, each machine will independently affinitize the worker processes appropriate for the machine it's running on. Does that answer the question? Okay.
I think there's another question in the middle.
Yes. The question is, does this mean you need to store the session state out of process? The answer to that is yes, you do. This is one of the biggest challenges I think people are going to have adopting not just large scale-up situations. I think people are going to start having to think this way in any use of the cloud. The other thing, the IIS team is a part of one of the Azure teams. And so we have IIS workloads with coworkers of ours that are running in Azure. And what we see there is that worker processes can be started up, started down, or moved at will. And so moving forward, we strongly recommend everyone to move away from an in-process session state model because you will lose session state when things get moved around. The single biggest question, the single biggest piece of guidance I would have for someone trying to run one of these large machines, very first question I would ask is, do your applications require a single process in order to run? And if the answer to that is yes, you wouldn't be able to use this new feature. I'll talk a little bit about what that means from a performance standpoint. If the answer to that is no, I don't require session state, or no, I have a shared session state that can work with multiple processes, the simplest thing you can do to get good performance is just change this from the default 1 to 0. And you'll get everything I've talked about so far just automatically. Any other questions? Okay. So I want to share some performance numbers. The reason I don't want to publish these numbers and the reason I don't have a slide for them is it would be very difficult to put enough caveats on how the numbers came about and what they actually mean and whether you could reproduce them. We've worked with a few large hardware vendors to put together some of these machines up into the hundreds of cores and done a bunch of performance testing. Our performance load is not a typical load that you would see on a production web server. What we do is we make a request that's only 512 bytes to whatever the server is, measure the maximum throughput we can get when we do that. And the reason we pick a really small number like that is we want the response to fit in a single TCP packet because we don't want to see the TCP characteristics in the measurements we get. We also request static file pages and not dynamic application like ASP.NET. And the reason we do that is we don't want to measure ASP.NET's performance in this particular case. We want to see how much overhead IIS itself imposes on serving responses back. The numbers I'm going to give you also have all caching turned off, which can be disabled. So I'm going to give you some numbers that are really large. These are actual numbers of IIS producing responses. They do not represent kernel cache. With the kernel cache, they would be even faster. The hardware machine in this particular case is running 64 physical cores. It has 8 NUMA nodes on it. So the way Intel is currently implementing NUMA is on a NUMA machine, they have 1 NUMA node per socket, which is the physical microprocessor, the physical CPU package, they call it. So it's one chip with 8 cores in it, and then there's 8 sockets, so it has 8 total chips. We have 1 RSS queue per core. An RSS queue is a network device. What it means is I want to affinitize the work associated with I/O for that particular set of network requests to a particular NUMA node. So it's effectively affinitization at the network card level. And so we have 1 RSS queue per core. We're setting 512 byte static requests. We have 4 physical clients. Each physical client is running 25 virtual clients. So each of the 4 machines is making 25 concurrent requests. So we've got 100 virtual clients. I believe we have 10 gigabits per client dedicated to the server. So the biggest challenge for us doing this is network bandwidth. We rapidly flood the network on just about every configuration that we set up. So to do this, we're looking at about 40 gigabits of bandwidth between the test clients and server. Out of the box, if you have a situation with in-proc session state and you're not able to use this new feature, when we run with a full 64 cores, we see about 127,000 requests per second. If we adjust the machine to only use 32 cores, we actually use a little bit more. We actually see a little bit better throughput. We see 133,000 requests per second. And the reason that we see that is because of all the work the machine has to do to move data to the correct NUMA node. So we've got one process running on all 64 cores, and the core that's processing the request is very likely not attached to the local memory. So in almost all the cases, the requests are reaching across NUMA boundaries. And so we actually see 64, not as performant as 32. At 16, which is the smallest set we test with on this machine, we see 118,000 requests per second. So the scalability curve would go from 118,000 up to 133, down to 127. Those are big numbers, but they're not what we really want to see if we have a machine that size. So I'm going to go from that's the worst performance that we saw in our testing. I'm going to go to the best performance that we saw in that testing. Now, to achieve the best performance, we had to be on the phone with the hardware vendor, and we had to say, okay, we've got 8 physical slots. Each slot has a network card in it. We need to know where that network card connects to which CPU so we could figure out which NUMA node it was so that we could properly set up the RSS queues. When we go to the trouble of doing that, on 16 cores, we jump to 144,000 requests per second. 32 cores, 313,000 requests per second. And then at 64 cores, we're all the way up to 381,000. And so we're happy with those numbers. We see good scalability all the way up to 64 cores. And we see very high specific throughput with a low overhead introduced by IIS. People don't want to go through and do that manual work that I just talked about. So I do have a set of numbers that is what happens when you change this number from 1 to 0 with your single app pool. And in that case, on the 16-core configuration, we see 127,000 requests per second. That's the same number by coincidence we saw with all 64 cores and not setting that to 0. 32 cores takes us up to 214,000 requests per second. And then at 64 cores, we have 285,000 requests per second. So it's a substantial improvement over what you would get with IIS 7.5 or what you would get without making any configuration changes. But if your application doesn't require in-proc session state, you can see you can get pretty good numbers without analyzing the machine just by changing that one configuration setting.
All right. Let's go ahead and switch back to our slides here. Let's go ahead and wrap up. So today we kind of gave you an overview of some of the common topologies that are used for cloud hosting and highlighted some of our investments in IIS 8 in order to further scale the server. So we talked about our configuration, scalability. We talked about SSL improvements. Talked about application request routing and the elastic scale scenarios that enables, and the sandboxing in order to isolate tenants and keep them from interfering with one another. So all of these things put together really help make IIS a great platform for the cloud and for shared hosting in the cloud. That's some boilerplate slide they make us put in here. The thing I wanted to talk about a little bit was our upcoming session. So the top session there is the one that you're in right now. On Thursday morning, we have the next session in this series, What's New with IIS 8, Performance, Scalability, and Security, where we'll be delving into some other features that we didn't touch on today.
So in this talk was our cloud talk, and so even though there were most of the people in here running enterprise scenarios, most of the content in this talk was about hosting and other back-end web farms. The talk that we do on Thursday morning is going to be more specific to IIS straight up without a server farm.
Right. And finally, on Friday, we have an IIS Express for web developers talk, where we'll be introducing that IIS Express product and talking about why you might want to consider it for your web development scenarios. And I also want to mention we've got a great site out there called IIS.net. This is the place to be if you're an IIS user. We've got a lot of learning content, blogs from product team members, forums so you can get help with any questions you have, and then all of our extensions for IIS are freely downloadable there on the website. And with that, that's the end of our presentation. We're happy to answer any questions that folks have.
Yes? So the question is, how can I deploy to the shared configuration? Correct? Okay, so the assumption that we're making here is that you have shared content and shared configuration. If that's the case, you would publish your content to the shared location, and then you would make your configuration change to the shared location, and all of the machines in the farm would pick up the new configuration and run with it. Where you could potentially run into a problem is if you publish the configuration before you publish the content, then the machines wouldn't be able to get the content. So. Yes. So the question is, what's the customer experience? What does the client see when we invoke the network bandwidth throttling? It's transparent to the client. What the client sees is a server that simply can't serve as many requests. So that we don't kill requests or anything like that. Yes, the requests are being queued, and that's completely transparent to the client that that's happening. Yes. So the question is, what does recycling do? For memory, you're talking about. The answer is it depends. For network bandwidth, it works as I just described. We end up just reducing the bandwidth available. It's transparent to the client. They don't know anything's happening. They just see the server's limit handles a certain amount of traffic. Generally, that's true for the recycling, for the throttling features. The exception to that is for memory usage. The way the memory usage recycle works is we monitor the amount of memory used by a worker process, and when it exceeds the configured amount, it recycles the process. And in recycling the process, we try to allow the requests in flight to drain. So if somebody's already made a request, and then we decide to recycle, we're going to give, by default, I think 90 seconds for those requests to finish. And if all the requests finish in 90 seconds, the client won't see anything. If it takes longer than that for the current requests to all wrap up and go away, then we kill the worker process, and at that point, the clients will see errors. Now that timeout, the 90 seconds is configurable. When this, not to a second server. The recycling is all contained in a single server. So what we would do then, ARR could continue to send requests to that server. A new worker process would come up and start handling them. Or you could configure ARR to start sending the requests to a different server. And in that case, they would get sent to a different server transparently. Okay. Yes? I didn't catch the whole question. The question is, did we think about other enrollment schemes for centralized certificate store? Oh, do we think about automatic enrollment? No, we specifically went after just the copy to a file share enrollment is what we did there. And that's the scope of that feature. So if you have a feature suggestion, though, let me know, and we can look at it for the next version. Yeah? So the question is, for the WCAT, which stands for Web Capacity Analysis Tool, do we have the ability to drive requests based on IIS logs? The answer to that question is no. We've actually talked about that for many years now, but because it's a test tool and not part of IIS itself, it tends to sit at a lower priority on our workload, and it also tends to be harder to do than you might think originally. So we've taken a couple looks at it. We just haven't had the resources to get to that, but we look at it again periodically. That's a great answer. So the answer from the audience is that Fiddler supports extracting requests and then exporting them to WCAT. Thank you very much for that. That's great. Yes? The question is, if you lose connection to the file store for centralized certificate, what happens then? The answer is it depends. There is a level of caching that happens there's a component in Windows called S-channel. S-channel actually implements the SSL processing on the server. S-channel has its own caching. So if a request has recently been made to a site and centralized search store has sent the certificate, that site will be able to continue to run even if the centralized certificate store goes down. If a new request for a server comes in that hasn't been seen before, we obviously wouldn't be able to get the certificate in that case, and the SSL request would fail. Yes? And the answer is roughly the same for shared configuration. The question is, it's the same question. Yes. Right. So the question for the suggestion from the audience for both of those scenarios is to use a feature in the SMB share called offline availability. And you can configure offline availability for either the centralized certificate store or for shared configuration. The caution I would have on that, we've tested that feature, and we find that at the kind of scale and the kind of performance we require to be able to use the shares, we actually don't get that to work really well for IIS, just because our volume of requests exceeds what it was designed to handle. We are working specifically with the SMB team for the next version to look at ways that they can accommodate the scale that we have so that we can use the feature you're talking about. So to answer the question, to add my guidance to that, if you have a small enough level of traffic, that will probably work for you. But if you have a very large volume of traffic, the offline availability for SMB just wasn't designed for that kind of scale. Yes? So the question is, for the new web certificate store, why did we create that, and why didn't we just fix the personal My Store? I'm actually not the right person to answer that, because that decision was made by the team that owns the certificate store. Presumably there's some legacy that they wanted to preserve with the old store, but I don't know for sure what that is. Anything else? Okay. Sean and I will both be at the talk on Thursday. I think we're both planning on attending the Ask the Expert session Thursday evening. So if you have any more questions or want to talk about IIS at all, feel free to hit that session or come to Ask the Experts.
All right. Thank you for your time.